Hello and welcome to another edition of A Parent's Guide to. Today we are going to be looking at shape and the language that we use when we're describing shape in our classrooms. I think it's a really interesting discussion because certainly the mathematical language that we have will probably amaze you at how complex it is. But I'm always impressed with the children at how they can tackle this language. And I think to have that connection between home and school of using the same language would really help them. As ever, I've created a PowerPoint to kind of guide you through the main points. And I've got some shapes here that I'm going to talk to you about. So I'm going to share my screen and we'll get underway. And let's go. So here you can see a visualizer where I've got some shapes already there for you to look at. And we are talking shape, a parent's guide. It will amaze you about the quality and the complexity of language used with children to explore their understanding of shape, especially in years 1 and 2. And that's always the interesting part. When our children are the youngest, I think that the level of language that we're expecting them to use is certainly quite high. Parents can play a pivotal role in reinforcing this language when encountering shape in everyday life. And in today's presentation, I've not necessarily pinpointed everyday examples of these shapes, but you'll know exactly where they are and where you might share them with your children. Properties of shapes. So we would describe how a shape is made, if you like, and we'd use the word properties of shape. And that's a kind of easy guide for you. But I'm just going to explore that with some shapes that we've got here. Now, one of the key words to use is vertices. Now, vertices is probably the posh word or the mathematical word, if you like, for talking about the pointy parts. So if you look at this square, it has got 4 vertices. And we would use the term vertices right from year 1 for children to understand that this is a vertex and a vertices. You might want to say it means the pointy parts, but that's how we would describe it. Also, the key properties, the key ways we would distinguish a square between a rectangle is that it's got 4 equal sides, and we use that word 4 equal sides. Further up the school, we might start to talk about right angles, and we might use that to describe angles, but certainly year 1 and year 2, the key language would be equal length sides and 4 vertices. We might talk about parallel lines and lines of symmetry as well in upper school, years 5 and 6. And we would encourage children to create and explore those properties with their shapes. One of the key things that we would use when talking about shape is we might ask the children to tell me why this isn't a square. Why isn't it? So to know what something is, you've got to know what something isn't, you've got to know what something is. And this isn't a rectangle because opposite sides are equal. It's got 4 vertices in the same way, and it's got 4 right angles, but the opposite sides are of equal length, and the 4 sides are not the same length. Moving on to look at circles. Now, circles are really interesting, that debate on does it have any sides? Does it have one edge? Does it have one side? And you can see that there are no sides. It's got a curved edge. It's got a curved edge. And in years 5 and 6, where we come to explore symmetry, it's got limitless lines of symmetry, and we would really encourage the children to explore that, to test that generalization for themselves. And we've got the semicircle there with one side. Well, why isn't this a circle? Because it has got one side. And you can see that in my shape. It's got one curved edge and one side, so that's why it wouldn't be. Moving on to look at triangles, I've pinpointed 2 triangles here to talk to you about, and I'm just going to move my slide further on to show the different triangles. Here, types of triangles. So I've got 2 to show you here, and I have got this triangle here and this triangle. So if we were looking in year 1 and year 2, we'd only be saying that they're both triangles, and we know they're triangles because they've got 3 vertices. That's how we know they're triangles. A shape with 3 vertices is a triangle. Further up the school, we'd start to look at what's different and what's the same. So I can see that this shape here has got 2 sides of equal length. And I always look for ways to help children remember that. And this is named as an isosceles triangle, and that's the mathematical term for it. So whenever I teach isosceles triangles to help children remember, I try to relate it to sausages, which sounds very strange. And I might say something like, I would only eat 2 sausages. 2 sausages, isosceles. It's a triangle where 2 sides are of equal length. When I look at this triangle, I might describe it as an equilateral triangle. And I think that's always easier to understand because equal gives me that the sides are all of equal length. And we've got another equilateral triangle there. And here we've also got a triangle that's right angled. So we've got a right angle here. So we've got an equilateral, a right angled triangle and an isosceles. And we would be getting the children to distinguish between the properties of their shape. And if we go back to properties here, we're looking at equilateral triangles, got 3 equal vertices. So we've got 3 vertices, equal sides and 3 lines of symmetry. But again, that will be the exploration further up the school. We would want the children in years 1 or 2 just to recognise that a shape with 3 vertices is a triangle. Now, going back to one of our key definitions of shape is the word quadrilateral, quadrilateral. And we would encourage the children to recognise quadrilaterals because it's got the word quad in it. And some of them might know quad bike and know that a quad bike has got 4 wheels, 4 wheels, 4 tyres, whatever you like. And that would be the key terminology for shapes that have got 4 vertices. So a quadrilateral is any shape that's got 4 vertices. And you can see in this poster here, we've got the rectangle, we've got the square, we've got the rhombus. So you can see there 4 sides, all sides of equal length. 4 angles, not always right angles, and 4 vertices. So rhombus is often one that we would encourage the children to explore. And the trapezoid here, oh, that's not a true trapezoid actually. You might call a rhombus as well. And we've got a parallelogram there. So you can see there, parallelogram is almost like a squashed rectangle. It's got 2 pairs of parallel sides and not all of the sides are equal. So there are quadrilaterals, there are shapes, our 4-sided shape. And if I were looking at a regular quadrilateral, regular just means all the same. So this is my only regular quadrilateral because 4 sides are the same length. This is my only regular triangle because all sides are the same length. And that's what regular means. Moving on. So here, I'm going to go back to my properties of shape. This shape here has got 2, 4, 6, 8 sides. So it's an octagon. And we would obviously make the link between octopus and octagon. And children would be able to understand that that is an 8-sided shape. And it's a regular octagon because all of my sides are the same length and it's got 8 vertices. So 8 sides. And so when they go up to years 5 and 6, we might talk about interior angles, and that's the measure of degree. But certainly in years 1 or 2, we would just be calling that an octagon. I don't have one here to show you, but a hexagon would, oh yes, I do. But a hexagon would just be the same, but a 6-sided flat shape. So a 6-sided flat shape with 6 vertices and 6 equal lines. So there are some of our 2D flat shapes that we would use, and we would teach the flat shapes first, because when we come to look on 3D shape, you would see that some of the faces, here we go, are made up of those 2D shapes. So we would always teach 3D, we'd start off first, and we would move towards looking and finding those faces on a 3D shape. I'm just going to move those out of the way. I'm going to bring in some of our 3D shapes. I'm going to start with the cube and the cuboid. We'd really encourage our children, and cube and cuboids are brilliant because they're in everyday life, aren't they? Boxes of tissues, boxes of chocolates, books, all sorts of things, cube and cuboid. Now, a 3D shape we would describe as a shape that takes up the space and its faces. So for example, a cube, the faces are squares. So a cube has got square faces. A cuboid is different because it's got 2 square faces and 4 faces that are rectangles. So if we were teaching those, we'd teach the 2 together and we'd ask children to say, why is this not a cuboid? It's not a cuboid because although it's got 8 vertices, so it's still got the vertices the same, although it's got 8 vertices, on a cube, all of its faces are squares. So you can see the progression in language and why it's important to make sure that we've got that 2D shape language before we start exploring the properties of 3D shape. Again, with my cuboid, 8 vertices in the same way. And sometimes we'd get our children to close their eyes to enable them to visualize that. So we would describe the 8 vertices. And now I'm going to look at the edges. So when we're talking about 3D shape, we're not talking about size, we're talking about edges. So I would explore 1, 2, 3, 4 edges, 5, 6, 7, 8 edges. And then I'm going to turn over to look at the rectangular faces, 9, 10, 11, 12 edges. And I find that children who maybe have played Minecraft or have explored shape and have talked about what they see and the faces and such are often those that can visualize the shapes really well. So do explore that. Remember the key vocabulary: vertices, faces, and edges on my cube and my cuboid. Now we can move on to look at prisms. Now I've got 3 different prisms here to show you. And a prism is your typical Toblerone. If you cut it, if you happen to cut your prism, you would find it exactly the same the whole way through. That's how we would describe a prism. If you cut it in a section, it would be exactly the same. The cross section will be exactly the same the whole way through. So let's explore some of our prisms. So I've got a triangular prism, And again, we wouldn't shy away from this language. We talk about this in year 2, a triangular prism. In year 1, we'd only cover the cube, the cuboid, the sphere, which has got just a curved edge. It's got no sides, no vertices. It's just got one curved side there. Cover the cuboid. And we'd look at the pyramid. There'd be very little differentiation between a square base pyramid and the triangular base pyramid. I'm just going to go and see if I can find one of those. Yeah, I've got a handy triangular base pyramid here. So in year 1, we would just expect them to know the terminology of pyramid, and that's fairly easy if you can link that to the pyramids, and the same language. It's got 4 vertices. 4 vertices and 1 at the top. So my square base pyramid has got my 5 vertices. And let's look at the faces. So I've got a square face, and then I've got 4 triangular faces. So I've got my square face and 4 triangular faces. So that's how we would distinguish. So why is a square base pyramid not the same as a triangular base pyramid? Let's have a look. Well, one of my faces is a triangle. All of my faces are triangles. So that's why a triangular base pyramid is not the same as a square base pyramid, because it's got the same amount of vertices. It hasn't. It's got 1 vertices less. Got 3 vertices there and 4. But all my faces are triangles. I nearly caught myself out then. So they're our pyramids. Maybe less likely to see in real life, the pyramid structure, unless you went to the Louvre maybe. But they're often quite fun to see if you can't point those out. And then let's just go back to our prism. So here we go. So we've got our triangular based prism. Here we've got our pentagonal based prism, and I just bought it to explore the language. It's got a pentagon as a face, so a 5-sided shape. It's got a pentagon as a face, 2 pentagons, and the rest of its faces are rectangles. So let's explore how many vertices it has. So you can see I've got 5 vertices and 5 vertices. So my pentagonal prism has got 10 vertices. It's got 2 faces that are pentagons and 5 faces that are the rectangles. Let's have a think about edges. Well, you can see I'm going to have 5 edges. And then I'd encourage to see 5 on the other pentagonal face, 5 edges. Now, this is the part that the children often forget, are the edges that run along the rectangle. So I've got 5, 10, 11, 12, 13, 14, 15. And they might start to make the connection between the pentagon and going in multiples of 5, 5, 10, and 15. So my pentagonal prism there. So same thing, my triangular prism, and I've got my 3 vertices here, and I've got my 3 vertices. So my triangular prism has got 6 vertices, and interestingly, I've got 2 triangular faces, and then I've got 3 faces off those triangles. So it's got 5 faces. Edges again, if we look at, we're counting multiples of 3 now because we're a triangle. So we've got 1, 2, 3 edges, 4, 5, 6, and again the 3 that go around it. So it's got 9 edges on my triangular prism. And the last shape we're going to explore is the hexagonal prism. So just the same, got 2 faces that are hexagons. I've got 1 face here and 1 face here. And I've got 6 vertices and I've got 6 vertices. So I've got my 12 vertices. And if I start to think about edges, I've got 6 edges, 1, 2, 3, 4, 5, 6. And children will be exploring this in a more practical way in the classroom with their peers. We would explore the misconception that they would often think it's just got 12 edges and forget the edges that run along my rectangles. So we're multiples of 6, 6, 12, 18 edges. And those are my primary shapes. And we would encourage children as well to talk about them, use the language, we'd explore it, and it'd be on the working wall. So let me just go through some of the other reference points I've put on this slide to help you identify how to talk to your children about shape. So vertex, and this is a poster that you might want to use. There are some key information. The plural of vertex is vertices, and because we're often talking about shapes that have got more than 1 vertex, we refer to them as vertices. A cube has 8 vertices. Quadrilateral, a shape that's got 4 sides, and they don't need to be equal. So you can see they're the names of all the shapes: parallelogram, rhombus, and trapezium. There on my poster that I've given you there. Types of triangles, we've covered that. We've covered the isosceles and the isosages, a triangle where 2 sides are equal length. We didn't talk about this last triangle, and I forgot because I didn't have an example. I never have found a way to help children understand the terminology around this, and it probably derives from a Latin name. It's called a scalene triangle, and that means that none of the sides are the same length and none of the angles. So it means all of the sides are different. So we generally use what we know to work out equilateral and isosceles, and if it's neither of those nor a right angle, it must be a scalene, where all of the lengths and the angles are different. Regular and irregular shapes. So when we get into year 3 and 4, we start to talk about whether the shape is regular. And again, you remember I mentioned regular just means that the angles and the shapes are the same length. These are still quadrilaterals, but it means that the sides aren't the same length and the angles won't be the same. So they're still a four-sided shape. This compound shape here, made up of more than 1 shape, is a quadrilateral because it hasn't got 4 sides, and that's a different shape there. Pentagon and hexagon. Notice you've got a regular pentagon here and an irregular. It's still a pentagon, but it's going to look different because all of the sides aren't the same length and all of the angles. And the same for the hexagon. We've got a regular hexagon that's got the same number of vertices, the same length sides, and the angles will all be equal. This is still a hexagon, but it isn't regular because they're not of equal length and the angles aren't the same size. In year 3-2, we start to explore the angles. So I'm just going to move those away to talk to you about angles and degrees. So if I look on this shape here, we look at angles as a measure of turn. We look at the degree that the angles turn. So we use it to describe and think about 90 degrees is a right angle. So this shape here has got a 90-degree angle. It's got a 90-degree angle. This angle up here is acute, and that means less than 90. And I always think the terminology of that is fairly simplistic. Acute means small, less than 90, cute, and acute angle less than 90. Children would explore the angles within a triangle equal 180 degrees, but actually for you in your role at home, just talking about acute and angles that are greater than 90 degrees, I'm not sure I've got one here to show you, we would call obtuse. Obtuse here. So this roof, it shows you in that diagram, has an obtuse angle. It's greater than 90 degrees. Degree, we measure angles and turns in degrees, and you can see there's a protractor, but again, you can get online protractors, but again, unless that's something your child's really interested in, just using that mathematical language would be enough at home. Parallel and perpendicular, they sound like incredibly grand words for year 3, but notice parallel we would just describe as a train track. The tracks are going in the same distance and they're moving at the same rate. One of the misconceptions around parallel, and I'm just looking for a pen to model this. One of the misconceptions that children might have about parallel is if the lines aren't the same length, they might not necessarily assume that they're parallel. Notice my hastily brought in piece of paper. So if I were to sketch in 2 lines that are parallel, these 2 lines are parallel to each other, but this line is slightly offset. They are still parallel, and sometimes that's a misconception that children can have. And I would show that they're parallel by just putting those 2 lines there. So parallel means they continue in the same direction as each other. Perpendicular, well, since the X factor, that's really helped, because you can see there how they've shown that X there, and perpendicular lines meet at a right angle. Circumference, diameter and radius, when we get into year 6 and we're talking about the language around circles, we're talking about the circumference, the circle, and we relate that to circumnavigate and to go all the way round. Perimeter, we would describe, that's certainly not just until year 6, we talk about the perimeter of shapes in year 3 and 4. Diameter and radius. So the radius is half the diameter, and that helps us when we go up into year 7 to start calculating circumference and such. This is a whistle-stop tour of talking to your children about shape. I have created a real handy, just a little bit of a guide for you to talk shape to your children. These are the words in early years they might use, and then we move up to year 1, year 2, year 3, year 4, year 5 and year 6. What I would say, no matter what age your child is at, it's really good to check that early years language, the way of describing shape, that the children have got a good understanding, to just check that prior understanding. As ever, all of this information will be uploaded to our website. So if you're clicking on this in the newsletter and you're not sure where to find this key mathematical language, it will be on our website and it will be a handy download. But please, if at any point there's some terminology your child's come home with, do get in touch with us here at Hanwell Fields, because we really want to help. Thank you for listening.